Okay, so today we're going to be doing laws of exponents because part of solving maths problems is understanding the rules behind it, okay? So what I'll do is I'll do two videos, one explaining the laws of the exponents and then the second one showing how you work out your problems using the laws, okay? So the first rule as a part of laws of exponents is x to the power of 0 will give you 1, okay? So that applies to anything. So let's say you have 2 to the power of 0, that would give you 1. Or if you have 3 to the power of 0, it would give you 1. So anything to the power of 0 gives you 1. And that is the first law of exponents, okay? So we'll use this in an example in the second video, but for now that's the simplest law that there is, okay? The second law is that x to the power of negative m will give you 1 and x to the power of m, okay? So a fraction. So basically, before I actually continue, these are all reversible. So 1 can become anything to the power of 0. And x to the power of m, okay, as a fraction, as the denominator, can become negative m, okay? So if you had 2 to the power of negative 3, it will become 1 and 2 to the power of 3, okay, which simplified can become 1 over 8, okay? So the third rule of exponents will be x to the power of m times by x to the power of n equals x m plus n, okay? So that also applies again to anything. So if you have 2 to the power of 3 times 2 to the power of 5, it will be 2, 3 plus 5. But please note that your bases have to be the same. So you can't do this with, say, ym times xn. Doesn't work. The base has to be the same. Okay, so if we had to finish this, that would be 2 to the power of 8. Okay, so that's the third law. Once again, it's reversible. So if you get, say, xm plus n, you can separate it to be xm times xn. Okay. The fourth law of exponents is xm and xn will be equals to xm minus n. Okay, so the reason why is because if you have a look at this one over here, negative m will become positive m in a fraction form. So like this here is sort of the same. The n becomes a negative when you move it from being at the bottom. So when it becomes part of the numerator, it's no longer the denominator. When it's the numerator, its sign changes. Okay, so to use that as an example, or to provide an example for that, if you had 2 to the power of 2, okay, make that a 3 since it looks like a 3, and 2 to the power of 2, it would become 2 to the power of 3 minus 2. Okay, so the fifth law is also quite a nice and easy one. So xm times n will give you xm times n, like that. Okay, so the n will times by the n m. Okay, so to use an example, if you had 2 to the power of 2 times by 4, it would become 2 times 4. Okay, like that. Then we have number 6, which is one like this. Okay, so if you get given something like this, where something is in brackets and then there's an m, and it's a fraction, you times the m by both the exponents of the fractions. Okay, so that would become xm and ym. Okay, the reason why is because if you had to work that out as a fraction, okay, x y to the power of m, remember x has a power of 1, y has a power of 1, and they times it by m, so 1 times m will give you x m and y m. Okay, just like number 6. So that again applies with any number. If that was 2 and that was a 1, it would become, so let's just do an example. say like that, times by 3, it would be equals to 2 to the power of 3 and 1 to the power of 3. Okay, so anything like that. If we had to do number 7, okay, 7 is xm over n. Okay, it becomes a square root, so it'll be n x m. Okay, and if you see anything like this, you can always do the reverse for any of these. Number 8 will be n over xy will equals to n square root of x times n square root of y. Okay, and then the last one will be mn x equals m square root n square root x. Okay, so these are the rules of exponents. I'd say the most common ones you use, obviously you will use all of them, but will be the first handful, especially the timesing. This one here you use a lot, this one you use a lot, this one you use quite often as well. So all of them you use, there's just some that I think you'll find pop up a lot more than others. So that's just a short video to explain what the rules are, and then in the next video I'll do working out to show you how we work out sums using these rules, which I'm sure will be more in-depth and will be able to help you to better understand how we use these rules.